With Inca version 7.1, a new oscilloscope technology has been launched. This video will demonstrate the main functionality of the new oscilloscope. We will start with some handling hints and the concepts of the different areas in the oscilloscope. Subsequently, we will show the major features. The new oscilloscope also uses the well-known setup with a central graphical region to display signal curves along a horizontal time axis. Usually to the right, you find a list with the names of the contained signals, and on the left, an area for the axes. The upper region of the new oscilloscope offers a toolbar, which we'll use later on. Now let's see how some data are being displayed. Just above the time axis at the bottom of the instrument window, there is an area for displaying digital signals. The area above the grey separator line contains the analog signals. Simply drag the area separator to optimize the size of the areas. To improve the visibility of a signal, the respective signal curve is highlighted when hovering with the mouse over the signal name. Moreover, the y-axis the signal is assigned to is also highlighted and shown in the axes area. To have an even better view, you can arrange the signals into different strips. As soon as a strip is created, you can benefit from full drag-and-drop support. You can also change the order of the strips by simple dragging and dropping via the strip gripper. Once more, you can adjust the heights of the strips as desired. This enables you to use the available space in an optimum way, even with a large number of signals in the oscilloscope. Now let's take a look at the toolbar. While you are acquiring data, or are even recording it, you might want to have a more detailed look at a certain signal behavior. Simply press the pause button in the toolbar and the data display is stopped. As you can see in another oscilloscope, as well as from the status bar of the experiment, data acquisition and optionally recording are continued. Now we're going to have a more detailed look. The event occurred just some moments ago. Therefore, we have to scroll back in time. Let's assume here are the points of interest where we want to see more details. We now use the zoom in button to get a closer view. To get accurate information on value and time, you can add cursors. Just drag and drop them to the relevant event. The values at the cursors and the time difference are shown in the graphical area. To make all details visible in additional columns in the signal list, you can just double-click the splitter. All this was done while pausing the data display. To get up to date again, press the play button and the latest samples are displayed. In the final section, you will see how easy it is to adapt the axis so that you can see all relevant data in the best resolution. Meanwhile, an additional strip was created for the signal fuel mass, but it may happen that the current axis range is not suitable for displaying all values that will be acquired later on. Therefore, dynamic axis adaptation is enabled by default. Now we start the data acquisition. Please concentrate on the axis behavior. As you can see, for each new sample which is outside of the visible axis range, the axis range is automatically enlarged in order to display all data. As an alternative, you can adapt the axis scale to the currently displayed data by the function Zoom to Fit. Selecting this function from the context menu of the axis considers only the data currently shown on this axis, without being influenced by data that will be acquired later on in the measurement. Besides the two methods demonstrated above, you can still adapt to any axis manually, either by using the Control key and the scroll wheel of your mouse, or by pushing the cursor up, down keys. This video has demonstrated some features of Inca's oscilloscope. First, we've explained the different oscilloscope areas. You have learned how simple it is to organize the graphical area by creating strips, and to shift a signal into the desired strip. Then you have seen how to access events easily which occurred during data acquisition and which you want to investigate in further detail. In the last section, you have seen some methods for optimizing the y-axis range, for example, through the comfortable dynamic axis adaptation. Further information on the YT oscilloscope is available in the Inca online help.